Hello, and welcome to Science with Mr. Morgan. In today's episode, we're going to talk about physical properties of matter, specifically Part 1. First up, let's look at what physical properties of matter are. And what do I mean by physical properties? Essentially, these are properties that can be measured or observed without matter changing to an entirely different substance. Typically, these can be detected with your five senses. Now, if you remember growing up what your five senses were, they are taste, touch, smell, hearing, and sight. That being said, do we taste a lot of things in the lab? No. Sometimes, though, we do taste, but generally speaking, we do not taste in the lab. Now, similarly with smell, remember that we waft things in the lab. We don't typically smell them directly. Anyway, physical properties deal with states of matter. So what are the states of matter? There are four of them, and they are solid, liquid, gas, and plasma. Only solids, liquids, and gases are common on Earth. So what about plasma? Plasma is prevalent within the sun. Now, examples of physical properties include, but are not limited to, melting point, color, hardness, state of matter, odor, boiling point, ability to conduct heat or electricity, ability to dissolve in other substances, and more. During the chemical properties episode, we will delve deeper into this, but a given kind of matter has the same chemical makeup and the same chemical properties regardless of the physical state it is in. This means that water is water regardless if it's ice or water vapor. Now, in regards to physical properties, solids have a fixed volume and shape. Liquids have a fixed volume, but take on the shape of the container they're in. And gases take on the volume and the shape of their container. Now that we've talked about what the states of matter are, let's look at the changes of state. And this occurs whenever matter changes from one state to another, and these changes are all physical. Again, changing from ice to water does not change the chemical properties of water. They remain the same. When a solid becomes a liquid, it is known as fusion or melting. And an example of this is an ice cube melting into water. When a liquid becomes a solid, it is known as solidification or freezing. An example of this is water freezing into an ice cube. When a liquid becomes a gas, it is known as vaporization or evaporation. And an example of this is when water is boiling and turning into steam. When a gas becomes a liquid, it is known as condensation. An example of this is when droplets of water form on the outside of a glass of ice water. When a solid becomes a gas without becoming a liquid first, aka skipping the liquid state, this is known as sublimation. An example of this is what happens with dry ice. It is known as dry ice because it doesn't get wet, but it is still very cold like ice. If left out and exposed to the air, it goes from a solid to a gas, skipping the liquid phase. When a gas becomes a solid without becoming a liquid first, again skipping the liquid phase, this is known as deposition. An example of this can be seen with frost. Water vapor in the air becomes ice on plants without condensing into liquid first. Now on the screen is a handy chart that shows everything that we talked about. Feel free to pause the video here and check out this chart. Now that we've talked about a broad overview of physical properties, which of the following is an example of a physical property of matter? Water freezing into ice, iron rusting, wood burning, or vinegar and baking soda mixing to create carbon dioxide and water? If you said water freezing into ice, you'd be correct. That is a phase change. Onto another physical property of matter, let's look at density. What is it? Essentially, density is how closely packed particles of matter are. And this is a very, very, very important physical property of matter. The tighter the particles are packed in, the greater the density. If we look at a bowling ball versus a volleyball, which one is going to be more dense? Generally speaking, bowling balls and volleyballs are similar in size. So we have to look at what they're made of and not just the size of them. Bowling balls are made of a solid substance, which is typically a type of plastic, And these are generally filled all the way through. Volleyballs have an outside that is solid, but the inside is filled with air. Air is less dense than solids because there are less particles squished into one space. And because of all of this air, volleyballs are generally less dense than bowling balls. If you were thinking bowling ball all along, you were correct. Good job. By definition, the density of matter is actually the amount of matter within a given space. And the amount of matter is measured by its mass, and the space matter takes up is measured by its volume. This leads to the formula of density being density equals mass divided by volume. So let's look at an example. We have a book that has a mass of 500 grams and a volume of 1,000 centimeters cubed. To determine the density, let's plug those numbers into our formula. Density will equal 500 grams being divided by 1,000 cubic centimeters. This comes out to be that the density of this book, in this example, is 0.5 grams per centimeters cubed. Now let's do another question, but this time you're going to write it down and try it yourself. What is the density of a liquid that has a volume of 30 milliliters and a mass of 300 grams? Pause the video here and try this problem for yourself. Now that you've unpaused the video, let's go over the problem. First, let us identify the specific numbers we are working with. The mass is 300 grams and the volume is 30 milliliters. Let's plug it into our formula. Remember, density equals mass divided by volume. If we take the 300 grams and divide it by 30 milliliters, we get 10 grams per milliliter as our final answer. Is that what you got? If so, great job. If not, go back and check your work to mine. And that brings us to the end of today's lesson. Until next time.